Have you ever wondered how a transformer in electronics works? A transformer is an electrical device that plays a vital role in power transmission and electronics. At its core, a transformer consists of two coils of wire, known as primary and secondary windings, wrapped around a magnetic core. Its primary function is to transfer electrical energy between two or more circuits, and this is achieved through a fascinating process known as electromagnetic induction. Now that we know what a transformer is, let's delve into how it works. The operation of a transformer is based on a fundamental principle of physics. This principle revolves around electromagnetic induction, a process discovered by Michael Faraday. When an alternating current flows through the primary winding of a transformer, it creates a fluctuating magnetic field around the winding. This magnetic field then penetrates the transformer's core, which is typically made of iron or ferrite. Now here's where the magic happens. The secondary winding, which is also wound around this magnetic core, is exposed to the changing magnetic field. This fluctuating magnetic field induces a voltage in the secondary winding. This phenomenon is known as electromagnetic induction. The voltage induced in the secondary winding isn't random. It's determined by the turns ratio, which is the ratio of the number of turns in the primary winding to the number of turns in the secondary winding. The amount of voltage induced in the secondary winding is determined by the turns ratio, which we'll discuss next. The turns ratio is a crucial aspect of a transformer's operation. It's simply the ratio of the number of turns in the primary winding to the number of turns in the secondary winding. This ratio directly influences the voltage transformation, as the voltage across the primary and secondary coils are proportional to their number of turns. So, if you have more turns in the secondary coil than the primary one, you'll get a step-up transformer. In an ideal world, a transformer would have no losses. However, that's not the case. In an ideal transformer, there are no losses, and the power in equals the power out. This ideal scenario paints a picture of perfect efficiency, where the voltage transformation from primary to secondary windings happens without any energy wastage. But alas, this is not the case in the real world. Real transformers, while striving to come as close to this ideal as possible, do exhibit losses. These losses can be attributed to several factors. The copper losses occur due to the resistance in the windings, and core losses are due to hysteresis and eddy currents in the core material. Moreover, there are also stray losses due to leakage flux, and additional losses due to mechanical vibrations and heat dissipation. Efficiency is a crucial parameter in transformer design, so minimizing these losses is a constant endeavor. The goal is to bring the performance of a real transformer as close as possible to that of its ideal counterpart. Transformers come in various types and configurations to suit different applications. From stepping up voltage to providing electrical isolation, transformers serve a variety of purposes. Let's dive into the different types of transformers and their applications. Firstly, we have step-up transformers. As their name suggests, they increase voltage levels, making them crucial for power transmission over long distances. On the flip side, step-down transformers reduce voltage levels for safe usage in homes and industries. Next up are isolation transformers. They play a significant role in ensuring electrical isolation between the primary and secondary circuits, thus providing safety and noise reduction. Auto transformers are a unique breed with a single winding. They have multiple taps for voltage adjustment and are often used in power applications. Lastly, we have special-purpose transformers. These are designed for specific applications like impedance matching, audio coupling and amplifiers, and more. So, you see, transformers are versatile and indispensable in the world of electronics. Transformers are rated based on certain parameters which are paramount in their selection. When choosing a transformer, understanding its ratings is essential. The ratings are like the transformer's ID, revealing its maximum power, voltage, current, and frequency capabilities, along with its temperature rise limits. These specifications aren't just numbers, they're the guidelines that help you choose the right transformer for your project. Now let's talk about safety. Transformers deal with high voltages and currents. Mishandling can lead to electrical hazards, so safety measures are critical. Proper insulation and grounding are the first steps to secure operation. Use safety equipment like gloves and goggles, and never operate a transformer with exposed wiring. In the end, remember, transformers are about transferring energy efficiently and safely. They're like the silent heroes in your electronic devices, working behind the scenes to power up your world. So, next time you see a transformer, you'll know exactly how it works and what to consider when selecting one.